Hi, Room 21 Rockstars, and welcome to the Science Matter Review. I hope that you guys had a great day in class. I cannot wait to share with you the results of the first ever Barrett Academy Bedroom Blitz. That's where the Academy teachers were today. And I also wanted to pass along the fact that our matter test, our Science Matter test, will be on Wednesday, regardless of whether or not we have a delay or closing tomorrow due to the weather. So our matter test has been moved to Wednesday. It gives you one more day to study. Tomorrow in class we're going to play some type of review game to kind of help you to get those concepts down a little bit more. And today I'm going to provide you another opportunity to practice some reviewing at home. Now, with a little over 50 days left in the school year, one of the major things that I really want us to look at, think about, and focus on is the fact that with middle school coming up so quickly, I really want you guys to start coming up with your own methods to study. You know, when I started these at the beginning of the school year, I was trying to show you some excellent studying techniques to use in the home that maybe you like. Maybe you could find one that fits your learning style or that really has worked for you. But as the year goes on, I want you to start thinking about, especially since we have a little over only 50 days left, what works best for me? And I just want you to use it. You don't need Mr. Reichard anymore helping you with your studying, but I am going to provide a little bit of practice today if you want to follow along. Now, the first resource that I would direct you to, because it's amazing, it provides practice tests, games, has a study guide at the bottom, and practice questions, would include SOL Pass, which there is a link under the class news section of our Class Fusion page if you are interested in visiting that. The reason I say that is because it is tied directly to our 5th grade SOLs. Therefore, all of the material that you review on there is directly what you may be tested on and what you need to know for 5th grade. So, we start off with matter. And I want you to I want to take you the whole way back to February. If you believe it or not, this is when we did this. And I said that you had to design an experiment to prove to me that air was matter. And then I gave you a bunch of different post-it notes, and you had to stick those post-it notes everywhere. Because we know that matter is anything that takes up space, meaning it has mass and volume. So anything that has mass and takes up space. Okay, so anything that takes up space, that's volume, and has mass, meaning there's matter inside of it. That is matter. So I could literally right now take this paper and put this label on anything. So that's the first thing you have to get down, guys. What is matter truly? Okay? And how can you prove to me the fact that certain things are matter and others might not be? How can you prove to me, if I just picked up this water bottle, prove to me that this is matter? How would you do that? Okay, that's what that experiment at the beginning of the unit actually looked at. Now I want to talk about the difference between kind of 4 different units of measurement, which we're actually going to be kind of enforcing in math class. And I'm sure you know what I'm talking about. So what I'm actually going to do is kind of divide my paper into fourths. And I'm going to label mass, weight, volume, and density down the side like this. And I'm going to draw a little line. It is key that we have these differences down. And I just did this on the back of this sheet of paper. If you don't have much paper available to you, I know I need to get some more printer paper. That's something that you can do as well. Okay, whatever works best. Now, Mr. Reichard, as you know, is a visual learner, a kinesthetic learner, so it really helps me to draw pictures to help me remember things, or maybe even symbols that might help you to remember something. Okay, so in class, when we were trying to tell these 4 units of measurement apart, these are different ways that we can measure matter. We had a couple of different demonstrations, if you remember. Okay, and the first 2 that I would focus on would be mass and weight. Okay, because these are kind of the same and they're kind of different. And what you're going to learn in math class very soon is when we actually go to the doctor's office or weigh ourselves somewhere, we call that weight, but it's actually mass. Okay, we don't go to the doctor's office and the doctor says, okay, now I need to take your mass. Okay, they say this is your weight, but technically it's your mass. Okay, we're weighing how much, we're finding out how much matter is contained within you. Okay, so mass, guys, is the amount of matter inside an object. Okay, and if you remember, okay, and I'm going to draw myself a picture. I'm going to draw 2 cups, right? And I'm going to put 5 pieces of matter in each, and then over here, I'm going to draw a larger cup, and I'm going to put 5 pieces of matter in that cup. Okay, so this matter would probably be a gas, since the particles are spread far apart, and they're taking the shape of the container, or they're just kind of filling the container as much as they can. So this container here, let me move this up for you guys, has 5 pieces of matter, and this container here has 5 pieces of matter, so therefore those containers have the same mass. Now, what's the difference between weight? So if mass is the amount of matter that is contained within us, okay, or any object, then weight, what is weight, guys? Yes, the amount of gravitational pull on an object. So the weight of something, guys, is how much gravity is pulling us down. And how do I remember this? Well, I remember Earth. I'm going to draw Earth is not equal to the moon. I'm going to draw the man on the moon. Okay. So remember, if we go up into outer space and we get on the moon, or if we could potentially get on the sun, but that would never happen, or maybe Mars, our weight would be different because there is not as much gravity on those areas. Remember the moon, there is some gravity, but it's only about 1/3 that of what is on Earth. So you would be 1/3 your weight on the moon as you are here. So weight totally depends on gravitational pull, and that's technically why when you go to the doctor's office, they're kind of weighing, they're kind of actually finding out your mass and not your weight as much, because they're figuring out how much matter is contained inside of you. Okay, so these are 2 units we need to know. And finally, we flip over to volume and density. Okay, so volume in math, we've been also, doing that with rectangular prisms. Volume, guys, is the amount of space something takes up. And remember how I showed you the graduated cylinder? I'm going to draw one real quick and then show it to you. I showed you the the graduated cylinder, not the gravitational cylinder. And if I filled this with water up to here, and I had a penny, and I dropped that penny into, I'm going to draw Abe. There's Abe Lincoln. So I dropped my penny into the graduated cylinder. It went to the bottom. And say that this water line rose to here. This first line, that means that is how much volume that this penny has. I would measure how much that is between those 2 lines. Okay, I'd take away the water, and I could figure out how much space does that penny truly take up. And now remember density, we really looked at that a lot. We tried to mix those formulas together. And I want you to try something really cool at home because I just found out about it. If you just have a can of diet soda laying around and a can of regular soda, get some type of plastic tub or something, put them both into water and see what happens, okay? Because we remember we talked about how density is determining how closely packed matter is in an object, okay? So how closely packed atoms or particles And remember, if something is more dense, okay, you could do the same thing here in the graduated cylinder. If I drop this penny into this graduated cylinder, into the water, and it went the whole way to the bottom, what would that mean about that penny in comparison to the density of the water? Yeah, that would mean that the penny is more dense than that amount of water. Okay, and if you do have the opportunity, I'll tell you guys what happens in class, and maybe I'll even show you. Like I said, take a diet soda can and take a regular soda can, put them both in the water at the same time, and tell me about the density. You can get yourself 5 house points if you tell me the result of that. And I'd like you to share it with the class because it is really, really cool, guys, if you have the opportunity to do that. Okay, so we've talked about all of the different ways that we can measure matter. Okay, so matter is anything that has mass and volume, anything that has mass and takes up space. We've talked about 4 different ways that we can measure volume. The biggest difference that we need to get down is the difference between mass and weight. Now I'm going to grab another sheet of paper and we're going to talk a little bit. And actually, in your science notebook, we way back took the states of matter hard cardstock page, and we kind of talked about the differences between a solid, a liquid, and a gas. And I know it's kind of hard to see right there. Let me try to expand my screen. Now, and you guys found this out with the quiz, okay? If I tell you, okay, and this is where I'm actually going to get a sheet of paper. This will be a great study tool as well as a sheet of paper, and I'm actually going to divide it into thirds. So I have my paper divided into thirds. Imagine right now, rock stars, that each of these thirds is the actual container. Okay? So I'm going to label the first one solid, the middle one a liquid, and the last one a gas. Now, the first thing that I want you to do is to draw the particles, okay, inside of each of these containers. So like I said, imagine that each of these thirds is an entire container. Draw the particles for me, show me what it actually would look like, and then you can compare your work to mine. Think about what we talked about in class, guys. It's really, really important that we get that down. Think about what happens when each of these phases of matter is put into a container. Now, pause the video if you're still working, because I really want you to kind of think about this. And then, here's my results, compare them to yours. So, for my solid, I showed the particles all tightly packed here. Okay, if this is my whole container, maybe this is an ice cube. The particles are so tightly packed that the desk that my computer is sitting on right now that I am filming from is a solid. There is no space between the particles. They're so tightly packed. Okay, they really take their own shape. Or they have a fixed shape. It doesn't change. You know, this desk, this marker, the shape of this marker does not change because it's a solid. The particles are so tightly packed together that they remain the same. Now, for a liquid, if this is my entire container, like I told you, the particles are going to fill the container. They're going to take the shape of the container that they're in. So if I poured water, imagine for a second that this is a cup, and I put the water in, it would come right to the bottom of my container. And finally, for a gas has no definite volume like we talked about in class. That means it has no set volume because the particles are filling the container and bouncing around really quickly. They're running past each other so very quickly. So they assume the shape of the container that they're in. The only thing that is keeping these gas particles right in this area is the fact that they're in that container. But as you can see, if you compare these three to one another, look at the differences, guys. Tightly packed together, they have a fixed shape, take the shape of the container, they're kind of loosely together, and a gas, they're just bouncing all over the place, but they assume the shape of the container for that reason. Now, I have a couple of questions with this that I want you guys to think about that are really, really important when we're talking about matter. And those would include, I want you to think about volume for each of these three things, okay? And we talked about this a lot in class, definite volume, meaning a volume that you could measure and it would not change. Okay, so definite volume, and in fact, I'm going to write that down. What I want you to do right now on this graphic that you're making is put a star under solid, liquid, or gas, or all of them. Which of these three states of matter has a definite volume? Go ahead and do that. Okay, guys, Think about it. So which of these three states of matter has a definite volume? I'm going to show you what I came up with. My solid has a definite volume. Why does a solid have a definite volume? Yeah, because it has a fixed shape. You know, I could take this ice cube, drop it into water, and find out the volume by figuring out how much that water rose in my graduated cylinder. A liquid has a definite volume because it takes the shape of the container. I could measure the volume of a liquid. Now, why did I not put a star under gas as having a definite volume? Because it's just taking the shape of the container that it's in. It is literally bouncing around. If I was trying to take the volume of a gas, how in the world could I measure that? That's why it has no definite volume, because it changes completely based upon the space that it is in. You know, the room that I am in right now, the carbon dioxide that I'm breathing out and the oxygen that I'm breathing in, those two gases, they are filling this container. But if I went into another room of a different size, that gas would have a totally different volume because it's either larger or smaller than the room that I'm in right now. So the only two phases of matter that have a definite volume are a liquid and a solid. Now I have another question for you. Think about how each of these flow. Okay, do they flow easily? Do the particles, you know, the parts of matter, do they flow easily, or do they flow kind of, is it a lot longer, or do they flow much slower? Well, for a solid, guys, they do not flow. Okay, they do not move. So I'm going to put no flow. No flow under solid. Okay, there's no flowing because of the fact that they cannot move or slide past one another. Look at how tightly that the particles are packed. These are not moving anywhere whatsoever. Now, for a liquid, do you think that the particles can flow? Yes, and they flow easily. Okay, so the particles flow easily, guys, because think about water. Okay, the molecules in my bottle of water are moving around, and they just continue to move and flow. So those molecules, those particles are just moving very fast. And finally, for a gas, do you think that the particles can flow easily? Absolutely. In fact, for a gas, the particles are flowing so quickly that they literally are bouncing around and striking off of one another and just going everywhere because they're filling the shape of the container that they are in. And finally, I want to bring up one other word that we kind of didn't talk about much, but we have in other units, and that's compression. Okay, compression. Compressible. Okay, so this paper is compressible because, watch, I can take it and put it into a small ball. Okay, I went from a big sheet of paper such as this to this. So I can compress this paper. Okay, I would be able to compress this bottle if I so chose. Yeah, but I would probably get a little wet there, kind of like Bill Nye the Science Guy in the Adams video. So what I want you to do really quickly, one last thing with the three phases of matter, is figure out, are each of these compressible? Okay. Or let's do it this way. There's one that is easily compressible. Which one is it, guys? It's a gas. So I'm actually going to record that word here so you can practice that a little bit. So a gas is compressible. The other two, a liquid and a solid, are not as easily compressible. Because here's the reason. Look at a solid. Can we take these particles and cram them together anymore? Not really. And for a liquid, they're pretty close. So the only ones where we can take the particles and cram them together a little bit more, compress them, would be the gas. Okay, so you have this entire page. If you've done all of the different things on here, bring it in for a house point. Okay, and don't forget, if you do that experiment with diet soda and regular soda and tell me the results when you put it into water and figure out the density, you can get yourself 5 house points. Now I want to talk about temperature. Okay, because that was another big thing. And we did a lot of this in class. We looked at a ton of different experiments with temperature and the 3 phases of matter. But I just want to make sure that we have it down pat. So here's what I want us to do, and I'm actually going to kind of reference our test, hint, 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 for some questions with temperature. Now, what I want you to do right now is think about if I increase the heat. Okay, so here's what I'm going to do. I'm going to hit increase heat. Okay, so I start with this. Think in terms of the 3 phases of matter. What would I end at if I increase heat? Now, if I decrease heat, what would I start with and what would I end with as I make something colder? So draw this really quickly. You may want to pause. So what phase of matter would go on this line? Okay, if I started at the very beginning, I'll kind of start you off. I'm going to start with a solid, okay? And here's what I would think of an ice cube. Okay, so I'm starting with a solid. Now I'm going to start increasing the heat. If I took that ice cube and put it in a thing of liquid, a boiling liquid, kind of like mac and cheese, like I showed you in class. So if that ice cube is a solid, but it's dropped into a thing of boiling water, what happens to it? Well, it becomes a gas. So as we increase the temperature of each phase of matter, it eventually becomes a gas. Okay. Now, when we decrease, so if I started at a gas, okay, I've got, or think of the water cycle like I showed you guys in class, evaporation. Okay, so that water goes up into the clouds, it's evaporated, and it begins to form condensation up in the clouds. Okay, so then it slowly becomes a liquid. That'd be like raining. So the water is evaporated, okay, and then it rains, and then finally, if I took that matter and made it even colder, it would become a solid. Okay, so it'd go back into the ice cube phase. Now, if you look at your diagram that you just drew, guys, notice patterns here. Okay, it's kind of literally opposite, and liquid's just kind of hanging out in the middle. Okay, so I really want you to think about what happens with the addition and subtraction of heat with the phases of matter. Now, the final thing that I just want to look at would be the comparison between atoms and molecules and mixtures and solutions, and we'll also talk about elements in the mix. So the substitute today, guys, passed out this study guide. I hope that you're using it to help you at home. We are literally going down through, and if you're kind of confused as to, well, how, Mr. Reichert, am I supposed to use this? Well, first thing I would do is rip it apart. And if you have somebody to help you study at home, that you can fold this in half, or you can fold it in half. You don't need anybody to help you, because let me show you what happens. So one side has questions and the other side has answers. So you could be sitting here with the question side, what is matter? Okay, and the person who's quizzing you would see, and then you could recite, well, matter is anything that has mass and takes up space. All things living and dead are made of matter. Okay, well, what is matter made of? And you can just go down here. Take your time with this and think about all of the different elements that you might want to include there. Now, as for what we're going to do next, we're going to start at the very smallest particle known to man that it cannot be seen by the human eye of matter. What is that, everyone? It is the atom. Okay, we're not talking about atom in class. We're talking about ATOM, the atom. Okay, that's the very, very smallest part of matter. It cannot be seen from the human eye, but scientists are able to see it with the aid of different technologies and microscopes and things like that. Okay, now, if I take an atom, okay, put a couple atoms together, that's, now I'm starting to create something. Well, what am I starting to create? I am starting to create an element. And what's that thing called, guys, with all of the elements on it? Does anyone remember what that thing was called? It looks like a bunch of different squares put all together. Yes, the periodic table of elements. Okay, go ahead and, it's in your notebook. I copied it for each of you, but it looks a little something like this. Okay? Now, if this is the smallest particle of matter, and then we take a couple of atoms of the same type of atom, bring them together, and we get all of these different individual elements. Well, there are a little over 100 elements known to man, and all of these elements, either by themselves or combined to make a compound, form everything that we know. Everything around us. This chair that I'm sitting in, this pen, my phone, this water, this bottle, every single thing is made from the periodic table of elements. Okay, now, as you guys know, you don't need to know the elements. Okay, I'm not making you memorize a periodic table or anything like that. That's not the objective. The objective is to know that, and I would actually use this diagram, maybe put down what each of these things is, because then eventually you can kind of put your paper like this and you can kind of go in order. You know, we're starting at the very smallest part of matter and we're going up. It is, though, important with the periodic table of elements and elements alone to know that everything known to man is made from the substances on this periodic table of elements. So if an atom is the smallest part of an element, okay, now we're actually going to move into compounds. So these two actually kind of fit together, okay? Now, a molecule when you take a molecule, okay, and put either a couple of the same together, you get a compound that would be a pure compound. It's just of one element, like aluminum foil. It's only made from aluminum, the only element. It's not mixed with others. But then you also get different compounds, and we actually made some of those in class, guys, with the gumdrop, so if you remember that. So what I want you to do with both of these, because these are huge, and kind of their relationships with one another. Okay, so we have a molecule, which is the smallest part of a compound when we break it down. Now, how do we get a compound, guys? I actually want you to take some time to jot that down and write down a few compounds that either we discussed in class or that you know. And let me give you a hint right now. Refreshing water. Write down a couple compounds. Okay, guys, so compare your work to mine. So I said that a compound was two or more different elements combined, okay? Now, we can break that down to get a molecule, because remember, a compound is not pure. It has a bunch of different elements put together, all as one. That's why the molecule is the smallest part of a compound, and that is why we call the smallest part of an element an atom. Now, my example, as I just showed you, as I was getting a drink, would be H2O. This is a compound. Why? Because we have two parts of hydrogen. Notice it says H2. That means there are two hydrogen atoms and one oxygen atom because there's no subscript there. So H2O, when I take hydrogen and oxygen, put them together, I form the compound water. That is very, very familiar to everyone on the planet. Another one would be table salt. You know, the salt that you put on your mashed potatoes at night, or maybe your corn. That is also a compound, and that is formed from sodium and chlorine, NaCl. So if I look at that, guys, that means that there is one part sodium and one part chlorine. It doesn't, you know, that there are no two of this or two of that. So compounds are huge. Remember last time we also talked about C6H12O6, but I want to be sure that I'm giving you the right number. C6H12O6, I believe. Let me double check on that, but that was glucose. So that means there are 6 parts of carbon, 12 parts of hydrogen, and 6 parts of oxygen. Now, you don't have to know these guys, but I do want you to know, and you might, you know, everybody should know water, H2O. But you do need to know that when you take two or more different elements and bring them together, you get what we call a compound. Now, the only way that a compound can form is through some type of chemical reaction. Okay, so when water is formed, there has to be a chemical reaction by taking the hydrogen and oxygen together to form the water. Okay, let me think of anything else that you probably should work on there. You may want to just jot down a few examples of elements. Okay, so these two are huge. Examples of elements. Pull out that periodic table. Name some right now. Well, we have oxygen and hydrogen and carbon and helium and potassium and iron, all of those different elements. Those are all individual elements. Okay, if you bring in both of these with some examples of each, you can get 1 house point each. So I'm going to record the house points on my pages so far. So far you could get 1 for this page, 1 for this page, 1 for the page, and I already seem to misplace it. Oh, I see it over here. And 1 for all of your measurement. And then you could get 5 if you perform that experiment with diet soda and regular soda at home to figure out density. Okay, there's a few other things that I want to cover before I leave you. I know that this has turned into a very, very long study session, but it's definitely pretty awesome, and you guys were really enjoying the science unit this time around, so we really learned a lot. The only other difference that I want you to do, and what I would do, is fold my paper in half. You need to know the difference between mixtures and compounds. Now, what I want you are mixtures and solutions. The major thing I want you to think back to, guys, is what did we use with food in class to tell the difference between these? Well, we had 2 different things. We had Lucky Charms and we made Kool-Aid. So what is the difference there? Well, there were really 2 major differences, and I want you to fill them down in this kind of T-chart and actually jot down some other examples that you may know of mixtures and solutions, because that would also be very helpful for you as well. So if you remember, the Kool-Aid was a solution and Lucky Charms were a mixture. What was different about that solution, about that Kool-Aid? Yes, guys, it was the fact that the Kool-Aid dissolved in the water. Because remember, right after you finished mixing up that Kool-Aid in that water, I said, okay, just kidding, I don't want you to drink Kool-Aid. I'm going to need all the mix back, but you can keep the water. And you guys looked at me like I had 5 heads, because you can't do that. Because a solution is when you take 2 different substances and one of them dissolves in the other. So that word dissolve, that was really, really important. So bring this in with some similarities and differences between these 2 things, and you can get yourself another house point. So far I'm counting up 4 house points if you've done all those things on the study video, and 5 if you want to do that density lab. Now, for going this long, the secret code, which is worth another 5 house points. So far you can get 10 house points if you do all the studying. The secret code is matter is everything. 5 house points if you say that to me secretly, but you had to say it with some enthusiasm, rock stars. Okay, now what I want to do really quickly is just give you a couple of questions. I'm not pulling these from the test exactly, but these are just some things to help you to think. Okay, so here's my first one. So when an ice cream is left out of the freezer, the ice cream changes from a blank to a blank. So think of the 2 phases of matter. So when I take ice cream out and I don't put it back into the freezer, what does it start as? It starts as a solid, I'm hoping, as long as your freezer is working, and then it becomes a liquid. Good. So I would say just be able to go back and forth with different things. Think about what phase of matter it started at, and think what it changes to when you add heat or take heat away. Increase or decrease heat. Here's a question for you guys. If I take a cup, okay, and I don't think I have, actually I do have a cup here. So if I put this water in here at the beginning of the day, but it was filled up to here this morning, and when I came home from school, the water level was a whole way down here. What happened? What happened? Well, yes, it was evaporation. I know that's what you're thinking because you remember the water cycle from 3rd grade. But also, what did this change from? I had a liquid, and most of it changed into a gas. Good, because it was evaporating. Okay. Let me look at some other questions. What is the smallest quantity, the smallest part of an element? Smallest part of an element is an atom, and the smallest part of a compound is a molecule. Very good. Which of the following is a mixture? I'm going to give you 4 choices. Tell me which of the following is a mixture. Remember, when I take a mixture, I take 2 or more different substances, I put them together, and none of them lose the properties that they originally had. So which of these is a mixture? Salt, water, lemonade, or sugar? Anyone know? Well, think lemonade. Lemonade is definitely a solution, ladies and gentlemen. Water is a compound, okay? Did anything dissolve in anything else? Well, we would have to do some research on that, but that's probably not a mixture. Salt, when you take sodium and chlorine and put them together, or sugar. Oh, and I left out one more, guys, and it would be trail mix. What would that be? Good, the trail mix. Okay. Let me look for another question for you. Oh, and here's a really good one. Actually, I think I might put that on your test. That's a really good one for the test. One more question. And this one's kind of open-ended. I don't want to give choices for this. I just want you to kind of be thinking in your brain, you know, what could happen here. What happens, what is possible with the addition of heat to any type of, to any of the states of matter? What is possible with the addition of heat? Well, exactly. It could become a gas, but it could also become a liquid. It doesn't always become a gas. You know, if I take an ice cube and I melt it, it's not going to become a gas that quickly. You know, evaporation is going to have to set in. But when heat is added, the potential for a phase of matter to become a gas is much greater. So, couple of review tips. Use the SOL Pass online. There are a ton of great study videos there. In fact, I actually printed out the SOL Pass study guide, which would be very helpful as well. You can also get the study guide that I had the substitute pass out to you guys today. I saw a couple on your desks when I came back, so I hope that you get that tomorrow. This is a great tool to use to practice all of those wonderful things that you need to work on. And finally, all of the things that you did today, you can get 5 house points if you bring in your work, 5 house points for telling the secret code, and an additional 5 house points if you tell me the results of the density experiment that I gave you at home. If you have those materials, you know, I know everyone probably doesn't have diet soda and regular soda, but if you do, and it has to be in the can form, put them both into some type of water, maybe fill up your sink, tub, something like that, and watch what happens to each of the cans. Do they both have the same density? It's a really cool experiment, in my opinion, and I want you to think about why. What is different with each of these things? So, I've given you all of the tools that you possibly need. I also am interested in seeing what you use at home that we did not use today. If you bring those into me, have a conversation with me about what study strategies worked for you that I did not provide in this video. I will also give you a couple of house points because I'm interested in seeing what are you doing to extend that learning even a little bit further, rock stars. I am so incredibly proud of all of you. I am so incredibly proud of your interest and intrigue with the matter unit, and I cannot wait to start sound with you on Thursday. But until then, you are the best students in Stafford County. Have a wonderful night.